Okay, this lesson we're going to take a look at neutralization of an acid with a base or an alkali. But before we do that, here's quick retrieval. You can pause the video and have a go at these 5 questions. Okay, let's have a go. What is universal indicator and what colour does it turn when there is an acid? Number 2, what colour does universal indicator turn when there is an alkali present? And number 3, why are acids acidic? Number 4, which ions are present in a base and in an acid? And number 5, give an example of a neutral substance. So now you can pause it and have a go at these 5 questions. Right, let's see how you got on. So what is universal indicator? Well, it's an indicator that shows whether something is not only an acid or an alkali, but it also shows the strength, whether it's a strong acid, weak acid, strong alkali, weak alkali. It has a range of 1 to 14. So 1 to 6 is acid, 7 pH 7 is neutral, pH 8 to 14 will be an alkali. What colour does it turn when there is an acid present? If it's a strong acid, it will be red, pH 1. If it's a weak acid, it will be yellow, pH 6. Ethanoic acid is pH 5, 6. Strong acid will be hydrochloric acid at pH 1. Don't forget, you need to know the difference between a strong and a weak acid. A strong acid fully ionizes and a weak acid partially ionizes. Number 2, what colour does universal indicator turn when there is an alkali present? So here, pH 14 will be blue, purple, that kind of colour. pH 12, 13, 14. Why are acids acidic? Acids are acidic because they contain the H plus ion. Which ions are present in a base? A base is a metal oxide, so it'll be oxide ion. And an acid, I've already told you, is H plus ion. And then give an example of a neutral substance. The best example is water. Got an extension question for you here. If I dissolve some salt into water, the salt is soluble, I end up with a salt solution. What would the pH of salt solution be? Think about this one. Okay? Well, it should be pH 7. Moving on. So, that's our objective for today. To know what happens when an acid reacts with a base and when an acid reacts with an alkali. So let's have a look. Write word and symbol equations to show how acids are neutralized by alkalis and bases. You can pause the video here. Right, if we look at this, then the general equation is acid plus alkali gives you salt and water. Even the other one is acid plus base is salt and water. And if you was doing the higher level, then it would be this equation. Aqueous, aqueous. Now the name of the salt will depend on, obviously, the acid used and the alkali or the base used, and we'll take a look at that a bit later on. Moving on. What has happened to this man? And how does this link to the lesson? You can pause the video here and have a brief discussion. Okay. Well, he's had some accident with an acid, something obviously acid has been, I don't know, poured onto his face, or acid has got onto his face. That's an acid. And if that does happen, obviously 999, remove the contaminated clothing and rinse with water immediately. What's a neutral substance? Pause the video here and have a go. Okay, well, it's a substance that has an equal concentration of hydrogen ions and hydroxide ions. Moving on. If you have an alkaline solution, what is needed to neutralize it? Well, you said acid. Now, I did mention earlier on, the name of the salt depends on the acid or the alkali used. This you must need to know. If you react any of these acids with an alkali, the name of the acid changes in the following ways. If you have hydrochloric acid, then you will get chloride salts. If you have nitric acid, you'll have nitrate salts. If you have sulfuric acid, you will have sulfate salts. And if you have phosphoric acid, you'll have phosphate salts. I suggest you learn that. Okay, let's move on then. Here is an equation and a few notes. So alkalis are soluble. So a typical alkali is sodium hydroxide, another one is calcium hydroxide. You will have heard of calcium hydroxide as lime water, where you bubble carbon dioxide through lime water and carbon dioxide turns lime water milky. Well, lime water is calcium hydroxide. Whenever an acid reacts with an alkali, you always make a salt and water. So there's your acid reacting with an alkali to give you salt and water. So the acid we're using is hydrochloric acid. The alkali is sodium hydroxide. What you need to remember, alkalis end with that word. Okay. There's your metal. So it's a metal hydroxide. Alkalis end with that word. There's your salt. So sodium chloride in this case. I did say hydrochloric acid produces chlorides. And the metal comes from the alkali. And then there's your water. And for the higher tier, you will need to do the symbol equation. So the symbol for hydrochloric acid is HCl. Sodium hydroxide, NaOH. And the salt, NaCl, and then water. Okay. So let's move on. Neutralize the following acids with the alkalis and write the word and symbol equations. And then there's an extension activity. Write the balance symbol equation and include state symbols. And then if you want, you can create your own equation using a different combination of acids and bases. So you can pause the video here and have a go at these. So you need to write a balance, finish off the word equation and then a balance symbol equation and see if you can include state symbols. This activity could take you 5 or so minutes, so you can pause the video here. Okay, let's have a look then, how you got on. So there's the first one, hydrochloric acid, reacting with potassium hydroxide. There's the hydroxide again, I told you. There's the metal. to give you the salt, potassium chloride, and chloride is because it's hydrochloric acid, and the potassium has come from the alkali. And then there's your water. And the balanced equation, hydrochloric acid, HCl, potassium hydroxide, KOH, there's your hydroxide ion, OH, and there's the salt, KCl, and there's your water. And it's balanced. The second one I asked you to do was the nitric acid reacting with magnesium hydroxide. Now, the salt you should have got was magnesium nitrate because the acid is nitric and the name of the metal is obviously magnesium. And there's your water. And the simple equation is HNO3, that's your nitric acid, magnesium hydroxide. I wonder if you did that. The brackets with the two outside. And the magnesium nitrate, again, brackets with the two outside. And there's your water. Okay. And then to balance it, there. So you've got now two NO3s over here and here. One magnesium. But you do have two hydrogens there and two hydrogens there. That's 4 hydrogens. So if you put a 2 here, 4 hydrogens. Now that also tells you you've got 2 oxygens, where you've got 2 oxygens here as well. So now that's balanced. Moving on to the third one, sulfuric acid, and with sodium hydroxide, there's your alkali again. And the salt is sodium sulfate. Now, once again, it's sulfate because it's sulfuric. And the metal is sodium because that's come from the alkali. That's the formula for H2SO4, sulfuric acid, sodium hydroxide. There's the salt, sodium sulfate, and there's your water. And it's balanced. Okay. Let's move on then. If we now have a base is not a metal hydroxide, a base is a metal oxide. Now, whereas alkalis were soluble, bases are insoluble. They don't dissolve. So, whenever an acid reacts with a base, you always make a salt and water. And here's an example. The acid is hydrochloric acid. This time the base is magnesium oxide. Now previously we have been using alkalis which ended with the word hydroxide, while bases end with the word oxide. The salt is magnesium chloride. Now it's chloride because the acid is chloric, and it's magnesium because the alkali is magnesium oxide. And there's your water. And then to balance it, there's your hydrochloric acid, there's the base, there's the salt, and there's the water. So I hope you can see the difference between acid and alkalis, and yet they both produce salt and water. And the other key thing is, I hope you can now name the salt, or if the examiner gives you the name of the salt, you can name the acid or the alkali or the base used. Let's have a look at some exam questions. So here's one. A teacher demonstrated the temperature change when hydrochloric acid is added to sodium hydroxide. Now, the fact that there's a temperature change tells you that a chemical reaction is taking place. This is the method used. Add 25 centimeter cube of sodium hydroxide, so that's an alkali, to a polystyrene cup. Measure the temperature of the sodium hydroxide solution. Add 25 centimeter of hydrochloric acid, so there's your acid, chloric, to the sodium hydroxide and stir the solution. Measure the maximum temperature of the solution. Draw a line from each measurement to the most suitable piece of equipment to use to make the measurement. So the temperature, what equipment would be used, the volume of acid, what equipment would be used. So pause the video here. It's worth 2 marks. Okay, let's have a look. So thermometer, a measuring cylinder, 2 marks. Move on. The teacher did the experiment 4 times. The table below shows the teacher's results. So experiment 1, maximum temperature reach. Experiment 2, experiment 3, and experiment 4. Calculate the mean, so that's the average, maximum temperature rise. But please pay attention to this. Do not use the anomalous result. Now, out of the 4 results here, you have got one of them is an anomalous result. An anomalous result is a result that does not fit a pattern. So the one that doesn't fit the pattern is this one here. So when you work out your mean, your average, do not use this result. So you can pause the video here and have a go. Let's have a look. So 6.1, add 6.1, add 6.4, divided by 3, there's your answer. Okay, moving on. How could the accuracy of the experiment be improved? Tick 1 box. So, looking at this, there you go. Use the lid on the polystyrene cup. 1 mark. You don't want to lose any heat. The reaction between hydrochloric acid and sodium hydroxide is a neutralisation reaction. The reaction produces a salt on one of the product. Complete the word equation for the reaction. Now this will be worth 2 marks. So you can again pause the video here and have a go. Okay, let's have a look. So there you go. The salt is sodium chloride, or NaCl, plus water, H2O. Universal indicator is used to measure the pH of solutions. Hydrochloric acid is pH 1, sodium hydroxide is pH 13. Draw one line from the pH to the colour of universal indicator in a solution with that pH. So pH 1 and pH 13. Right, let's have a look. Red and purple. 2 marks. And that's the end of this.